Welcome back. Now let us solve exercise 4.3. Now exercise 4.3 and 4.4 are very important exercises in this chapter. We are going to solve these two exercises thoroughly. Okay. Now 4.1 and 4.2 were very easy, straightforward, but here it may not be. Let us start with 4.3. First problem, if sine theta is equal to 5 by 13, sine theta is equal to 5 by 13, where the theta is an acute angle, find the values of other trigonometric ratios using identities. Now the major problem in 4.3 is students don't understand where to use which method. Okay, now here you may say that the sine theta is y upon r, so you can find out the value of r, and so that you can find out the cos and tan. But here they have used word using identities. That means you have to use these identities. Okay, based on this you have to find the answer. So remember which method is to be used when. We will read the problem again. If sine theta is 5 by 13, where theta is an acute angle means between 0 to 90. That means it will lie in first quadrant. Okay, x and y both are positive, or all the ratios will be positive ratios. Okay, so if sine theta is given, which identity will you use? See, whenever we have some equations and only one variable is unknown, it is very easy to find that variable. Now in which of the identities sine is used? Here. And in this equation only cos is unknown. So here you have to use the identity sine square plus cos square equal to 1. So I can write that sine square theta plus cos square theta is equal to 1. Hence substitute the values. 5 by 13 square plus cos square theta is equal to 1. So cos square theta is equal to 1 minus 5 by 13 square. Now please pause your video and find the value of cos theta. Please do it now. Simple numerical. How will you do that? Cos theta, cos square theta is equal to 1 minus 25 upon 169. So 169 minus 25 upon 169, that is 144 upon 169. So your cos theta will be equal to plus minus 12 by 13. But you need only one value. It's an acute angle. They have stated that is an acute angle. So all the identities are positive, or x and y are positive. So here we have to take plus 12 by 13. Now once you get the plus 12 by 13, so we have plus 12 by 13. Once you get cos theta, you know sine theta, you can easily find out the values of other identities: tan, cosec, sec, cot. So please pause your video here and find the values of all the ratios. Now this example is quite famous one because it appeared in October 12, March 12, March 15 for 2 marks. This example for 2 marks, very easy example. Only thing you have to decide, they have asked to use the identities, so you are using this identity, you are using this to find out the trigonometric ratios of sine, cos, tan, cot, sec, cosec. Okay, let us see next example. Second example, if cot theta is equal to minus 7 by 24, cot theta is equal to minus 7 by 24. Okay, find the value of sine theta and sec theta if the theta is in quadrant 4. Now when the theta is in quadrant 4, that means x is positive and y is negative, right? Now you know cot, so reverse of it will be tan. If cot is minus 7 by 24, the tan will be 24 by 7. Correct? So the tan theta will be minus 24 by 7, which is equal to y upon x. But now y is positive or x is, this is negative. Either of the value is negative. They are given that this is in fourth quadrant. That means y is negative and x is positive. So I will say that y is equal to minus 24, x is equal to 7. Now you can easily find a value of r, that is r square is equal to x square plus y square. Now why I have not used these identities here? Because they have not asked us to use the identities. So I am using this straightforward method. Okay, even if you use the identity like this, 1 plus cot square is equal to Seck-Square, here you can try that. 1 plus cot square is equal to cosec square. Correct? That means from here you will get the value of cosec, means you will get the value of sine. Correct? Once you get sine, you know tan, you can easily find out the value of cos, because tan is nothing but sine upon cos. Okay? So ultimately the calculation wise both the parts are same. When it is not given, you can use any of the method, but if they say use the identities, then you have to use the identities only. Here you can go by this method. Now quickly find out, pause your video here, quickly find out. Now you know x, you know y, find out the value of r, and based on that find the value of sine and sec. The sine is very easy, y upon r. To find out the value of sec, first you have to find out the value of cos. Sec is nothing but inverse of cos, so it will be r upon x. So please pause your video, find the value of r and find the value of sine and sec. Do it now please. So here r is equal to 25, sine theta is minus 24 by 25, and sec theta is equal to 25 upon 7. Please check your answer. So these are very easy problem, no confusion with this, but still students get confused. By which method shall I solve this? You can solve by any method unless it is given. It is asked to solve by a specific method, you can solve by any method. Let us do third example. 3 sine alpha minus 4 cos alpha is equal to 0. 3 sine alpha minus 4 cos alpha is equal to 0. Find the values of tan alpha, sec alpha, cosec alpha, where alpha is an acute angle. Alpha is acute angle. If it is an acute angle means x and y both are positive. Now by which method you will solve? You can solve by any method. Correct? Because no specific method is given or it is asked. Now can you see that? You can just transfer cos there. So we have 3 sine alpha is equal to 4 cos alpha. So we have tan alpha is equal to 4 upon 3. And you know tan is y upon x. So you have y is equal to 4, x is equal to 3. Very simple. And you can find out the value of r from this. So pause your video, find the value of r. R square is equal to x square plus y square, or r is equal to under root x square plus y square. Please pause your video and find out the value of r here. The value of r is 5. Once you get the value of r, you can easily find out what is asked, that is tan alpha, sec alpha, inverse of cos, and cosec alpha, inverse of sine. So simple example. By the way, when you have tan, you can even use this 1 plus tan square is equal to sec square and find out the sec. Once you know the sec, you will know the cos. Once you know the cos, you will know the sine and the rest of the ratios. Let us do fourth example. They are given if tan theta is equal to 1, then find a value of sine theta plus cos theta upon sec theta plus cosec theta, where theta is an acute angle. Theta is an acute angle means the value lies between 0 and 90. X and Y both are positive. Now how will you solve this? Again, there are two methods you can solve. First, if tan theta you know, then the value of y and x both are 1, 1. Okay, if x and y are 1, r is equal to root 2. Correct? And when you get the r, you can just find out the value of sine cos. And from sine and cos you can get sec and cosec. Correct? Then substitute here sine, cos, sec, cosec and you will find the answer. Correct? Or second method is, now first of all find the value of r is equal to root 2. Okay? X is equal to 1, y is equal to 1. They have not given that solve by the identities. So I am solving by the first method. Now again the variation comes. You can find out the sine, cos, sec and cosec values. Sine will be y upon r, that is 1 upon root 2. So your 1 upon root 2, 1 upon root 2 and sec will be root 2, cosec will be root 2. So first is this, your sine is y upon r. I am substituting in the given equation. So 1 upon root 2 plus 1 upon root 2 upon your sec is inverse of cos. Cos is x upon r, so it is r upon. So it is root 2 plus root 2. So I will get 1 upon root 2 plus 1 upon root 2 is 2 root 2 upon 2 whole upon 2 root 2. So I will get here 1 upon 2. Correct? Simple. This is the first method. I have solved this. The second method is, instead of filling the values here itself, I will solve it here first. That is sine, I am not writing theta, okay, but you have to write theta, or let me write, otherwise you will say sir is not writing theta, sir, so why should we write the theta? Okay, you should write the theta. Just for simplicity I am not writing theta, okay, but let's do it. Sine theta plus cos theta upon 1 upon sine theta plus 1 upon cos theta. Cosec I am taking here. So now I have sine theta plus cos theta upon sine theta plus cos theta, cross multiplication, upon sine theta cos theta. Okay, and so I will get, these two will get cancelled and I will get sine theta cos theta. And now I will substitute the values, that is 1 upon root 2 into 1 upon root 2, that is 1 upon 2. Okay, this is alternative method. Whichever method you find easy, you can go through that method. No problem at all in that, because they have not stated any specific method required. Okay. So this we have solved by this method of this R. But can you solve this by the method of identities? Yes, definitely. Now forget about all these things. Okay, you know tan theta is equal to 1. So can you substitute here? So tan square theta is equal to sec square theta minus 1. So I can even write it by this method, that is 1 plus tan square theta is equal to sec square theta. So let us substitute 1 plus tan square theta. Tan theta is 1, so square of 1 is 1, plus 1 is equal to sec square theta. So my sec theta is equal to root 2. Now once the sec theta is root 2, my cos theta is 1 upon root 2. Correct? It will be same as the previous case. Now cos theta I got it. Now sin theta I can get by this identity. 1 upon root 2. Correct? As tan theta is 1, the cot theta has to be 1 because it's just the inverse. So I can use this identity and find out the cosec and sine. Cosec and sine will be also same, root 2 and 1 upon root 2. Now you substitute there and you can find out the answer. So now we have seen multiple ways of finding the answer. My way is this. I like this way. Okay, that means first find out the value of r. Okay, find a value of x and y, find a value of sine and cos. Okay, simplify this and then use the values at end. My favorite method is this. I don't want to unnecessarily use two identities and find out the values and so on. Simply I can find out from here, I'll find out r, then I know this, I'll find out x, or I'll find out x and y, then sine and cos. So I'll immediately get cosec and sec. Then instead of substituting on the first step, I will first try to simplify this and then substitute the values of these two. You can find out sec and cosec values by this method or by alternate method, any method. But at the end, when you have to substitute it here, first simplify this and then substitute the values. Okay? So the first step is two ways. Either use identities. The first identity you can use tan, so you can get sec. Second identity you can use and you will get cosec. And alternately, by reversing it, you will get sine and cos also. So that value you can find out either by identities or by taking tan theta is equal to y upon x, find a value of r, and then find a value of sine and cos and sec and cosec. The next step, which is the common step for both, is this. Now initially I shown you that substitute here on the very first step, here. But why to unnecessarily make it complicated? Because trigonometric ratios are easy to solve than that of your numbers. So I simplify this, and at the end where only sine and cos is there, then at the end I will substitute the values for sine and cos. Correct? So here I don't have to find a value of sec and cosec at all, and they have not even asked for it. They have not even asked for it. They have just asked to find a value of this expression. Correct? So this is how these problems are to be solved. There are 2-3 methods. Whichever you feel easy, simple, you go by that method. Not necessary, it is not compulsory that you should follow the particular method if nothing is given. If they are asked to use identities, then you have to go by this method only. Otherwise, you use any method. Okay? Unnecessary, don't try to impress the examiners. He will not, if this sum is of 2 marks, he will not give 4 marks if you solve by some particular method. Marks will be same. So read example carefully, decide what to do, and then solve it. Let us see next example. Sec alpha is equal to 2 by root 3. Find the value of 1 minus cosec alpha upon 1 plus cosec alpha. Additionally, they are given where alpha is in quadrant 4. when alpha is in quadrant 4, x is positive and y is negative. Now this is very simple example. When you know sec alpha, cos alpha is root 3 upon 2. So here cos is x upon r, that is x is root 3 and r is 2. Find the value of y first. R square is equal to x square plus y square. Don't forget, in this case y is negative and x is positive, correct? So from there you will get sine, cos and tan, all you will get. Once you get sine, then cosec is just inverse of it. Substitute the value here directly, because here you cannot rationalize this. Okay, we'll see rationalization later. At this point you cannot rationalize. This itself is very simple. Directly cosec alpha is given, cosec alpha is given. So whatever the value of cosec alpha, you substitute here and solve the example. Please pause your video and solve this. Let us solve this. So we have cos alpha is equal to root 3 upon 2, which is nothing but x upon r. And that means we have x is equal to root 3 and r is equal to 2. X is positive because it is in fourth quadrant. So r square is equal to x square plus y square. So 4 is equal to 3 plus y square, and so we have 1 is equal to y square, and hence we have y is equal to plus or minus 1. But plus 1 or minus 1, it is in fourth quadrant, it is given. So in fourth quadrant y is negative, so y is equal to minus 1. So now you have x, r and y. So I will find out for cosec I require the value of sine. So cosec alpha is equal to r upon y, which is equal to minus 2. Substitute here. You can just substitute here and you will get an answer. So we have, from here we have 1 minus minus 2, 1 plus minus 2, that is nothing but 3 upon minus 1, that is minus 3. I hope you understood this. Now here also you want to find out the value of sine. So you can use sec. From sec you can find out the value of tan. When you know the value of tan and cos, we can find out the value of sine, because tan is nothing but sine upon cos. Tan you know, cos you know, sine is unknown, we can easily find it out. So by using identity also you can find out. By going by this method also you can find out. Whichever method you feel easy, you go by that method. Let us see next example. Example number 6. Find the possible value of sin x if 8 sin x minus cos x is equal to 4. So first rearrange it. I'll take cos there and 4 here. So 8 sin x minus 4 is equal to cos x. This is first equation you got. Now there is only one way, that is use this identity, sine square plus cos square is equal to 1, and you want to find the possible values of sine, so substitute for cos. Extremely simple. We have sine x square plus cos square x is equal to 1. We will substitute the value for cos. So here we have sine square x plus 8 sin x minus 4 square is equal to 1. Solve this and you will get the value of two values of sine. How? Isn't it a quadratic equation? If you consider sin x equal to a, okay, Actually it is not required, but in this kind of sums, after this 99% students miss the answer, because though it is a quadratic equation, they don't have practice to solve the quadratic equation which is in form of sine, cos or any trigonometric ratio. So simple method I'll tell you, consider, or I will say let sine x is equal to a. So here will be, so we will have a square plus 8a minus 4 square is equal to 1. So we have a square plus, we have to expand this, 64a square plus 64a plus 16 is equal to 1. And here we will have 65a square minus 64a plus 16 is equal to 0. Now this is a quadratic equation, we have already learned it. Okay, multiply 15 into 65 and then you have to factorize so that the addition is 64. Correct? So what factors will have? What factors will have? 65 into 15. 65 into 15. 13 into 5, and here I'll have 5 into 3. 39 and 25. So 39 and 25 will give you 64. So you will have minus 39 minus 25. Correct? So please pause your video here. I even given you the factor ready-made, spoon feed. Okay? So please pause your video here and find out the value of a. Please pause your video. So we will have 65a square minus 39a minus 25a plus 15 equal to 0. So here I'll get 13a is common, 5a minus 3 and minus 25 I have. So 5a, only 5 is common. So 5a minus 3 equal to 0. So I have 13a minus 5, 5a minus 3 equal to 0. So a will be equal to 5 by 13, or a is equal to 3 upon 5. But a is equal to sin x. So sin x is equal to 5 by 13, or sin x is equal to 3 by 5. This is our answer. Simple. So even if you are confident that you are very good in quadratic equation, don't try to solve this example keeping the sign here, sin x. Otherwise you will definitely going to miss the answer, because you don't have practice of solving quadratic equation in the trigonometric ratio form. Okay, I have solved this example for you just to show you how it is to be solved. Let us see next example. The question number 7, prove the followings. Now this is important part of it. Okay, because either one or two questions will definitely come as prove the following in trigonometry chapter. Okay, the first is, and generally these problems are for 3 marks. Now this problem, October 12 exam for 3 marks. The first is under root 1 minus cos a upon 1 plus cos a is equal to cosec a minus cot a. Now whenever these kind of examples are there, we will try to solve from left hand side to right hand side. Okay, by taking left hand side we'll come to the right hand side. Now here try to eliminate the denominator here. That is what called as the rationalizing. Okay, how you will do this? Rationalizing means, so from here 1 minus cos a, 1 plus cos a, I am rationalizing the denominator, means if I multiply this, now inside the square root sign, if I divide and multiply by some common factor, nothing will change. It is allowed. So I will multiply this by 1 minus cos A. Numerator and denominator both I will multiply by 1 minus cos A, so that the denominator will be eliminated. How? 1 minus cos A upon 1 minus cos A. Do you remember something? 1 plus cos A, 1 minus cos A. Is it not equal to x plus y into x minus y is equal to x square minus y square? Isn't it? So we will have here under root 1 minus cos A bracket square upon 1 square minus cos square A. So what is 1 square minus cos square A? It is 1 minus cos square A. And what is 1 minus cos square A? Identity. Sine square is equal to 1 minus cos square A. So we will get here under root 1 minus cos A bracket square upon sine square A. You have to write the reason. From sine square equal to 1 minus cos square A. Okay. So now both are the squares under square root. So we will have 1 minus cos A upon sine A. And hence I will just split, that is 1 minus sine A minus cos A upon sine A, which is equal to cosec A minus cot A equal to right hand side. So whenever such proofs are there, always try to first check if you can eliminate the denominators, and then if not, then try some other method. So let us see example 2. This example was for 3 marks in October 12 exam. Let us see second example. Second example is under root cosec x minus 1 upon cosec x plus 1 equal to 1 upon sec x plus tan x equal to 1 upon sec x plus tan x. I told you try to rationalize the denominator, but in that example right hand side was only numerator. Okay, there was no denominator. But now what you have? You have denominator here. Correct? So we will not rationalize this. In the previous example, here the numerator was, so we also don't want denominator here. So we rationalize the denominator. But in this case, here denominator we have on right hand side. So here it should be there. But numerator we don't want. So we will rationalize the numerator here in this case. Have you understood? If on the right hand side you have the numerator only, then try to eliminate denominator. Okay? Because their denominator is not there. But now here denominator is there, numerator is not there, it is 1. So we will try to rationalize the numerator here. I will multiply cosec x minus 1, cosec x plus 1, I will multiply and divide it by cosec x plus 1 upon cosec x plus 1. So what I will have? I will have cosec square x minus 1, as this is x plus y, x minus y, and here I will have bracket cosec x plus 1 bracket square. Now cosec square minus 1 is cot square, so I have cot square x upon cosec x plus 1 bracket square under root. So when root sign is eliminated, so I will have cot x upon cosec x plus 1. Now from here what I'll get? From here I'll get cot x is nothing but 1 upon tan x multiply by 1 upon sine plus 1. sine x plus 1. Now from here what I can do, tan is nothing but, this is nothing but 1 upon tan x into 1 upon sine into plus 1. Tan is nothing but sine upon cos, and this sine means 1 upon sine upon cos into 1 upon sine plus 1. So now this sine and this sine will get cancelled. Hence we have 1 upon cos is, when you open the bracket, 1 upon cos is sec x plus sin x upon cos x is tan x. Okay, when I open the bracket, for the first term this sine will get cancelled and we'll have only sec x and sin x upon cos x into 1, that is tan x. So ultimately we got this answer equal to right hand side. So here all your notations are not, hence it should be like this, equal to right hand side, which is proved. Okay, first see what is asked, what we want on right hand side, and then try to solve this. Okay, this is very simple, but such kind of examples are sure to come in your exam. Example 3, third sub question, sec-square x plus cosec square x, sec-square x plus cosec square x is equal to sec square into cosec square, sec square x into cosec square x. Actually it is theta there, instead of theta I have written x, doesn't matter, but in exam if it is theta you write theta, if it is x you write x, and whatever the variable is or the angle is. How will you solve this? Very simple. What is sec? I'll say that left hand side is equal to sec square x plus cosec square x. So this is nothing but 1 upon cos square x plus 1 upon sine square x, and from that cross multiplication. So I have sine square x plus cos square x upon sine square x cos square x. So by identity we know that sine square plus cos square equal to 1, and so we have 1 upon sine square x into cos square x. Write the reason, write this by identity sine square x plus cos square x equal to 1. So from here we got this one, and what we want, sec square and cosec square. So 1 upon sine square x is cosec square x and 1 upon cos square x is sec square x. So from here we have sec square x into cosec square x, which is equal to right hand side. Simple example, but this example appeared in March 14 exam and July 15 exam for 3 marks. For 3 marks, very simple example it is. So be careful in calculations, use correct identities and solve it. One thing I tell you, the more practice you do of this kind of examples, that is a prove the followings, prove that, you will get expert in that. If you solve a 3-4 examples, you will not become expert in this. You have to solve minimum 25-30 examples of this kind. So there are examples in your exercise, in your problem set. Then you may have the question paper sets, 10-20 papers you might have. From that, find out all such examples and try to solve these examples. Okay. The fourth example is very easy, but it is tricky. That means it is confusing. Students don't have the practice or habit of doing such kind of examples. Okay. Let us see this example. Fourth one is sec raised to 6x minus tan raised to 6 is equal to 1 plus 3 sec square tan square. Actually speaking, there is no meaning to this example. Okay, you give something and by somehow you find out this value. Actually it has got no meaning. But how will you solve this? We'll start with the left hand side. So your left hand side is, I can also write this as sec-square x cube minus tan square x cube, isn't it? Now, do you remember the formula for a cube minus b cube? A cube minus b cube is equal to a minus b, a square plus ab plus b square. I hope you know this formula. This is from the algebra, simple formula, and you should also know all such formulas. That is, a square minus b square is a plus b, a minus b. What is the opening of bracket? A plus b bracket square, a minus b bracket square, then a plus b bracket cube, a minus b bracket cube. All these formulas, you must by heart those formulas. Now can we make use of these formulas there? So now we have exactly that kind of formula, a cube minus b cube. So we will write sec square x minus tan square x into bracket this raised to 4 sec square x raised to 4 plus sec square x tan square x plus tan raised to 4x. Now by the identity, second identity, sec square x minus tan square x is equal to 1. So this bracket will equal to 1. Now how to solve this? Now can you see that if this is a square and b square, what we want in between? We want either minus 2ab or plus 2ab. Then it will be a complete square, right? So if we want that, we can take that figure and subtract, so that finally we will get sec square minus tan square. Correct? Let us see how. Here what we want? 3 sec square plus tan square. So I will have sec raised to 4x minus 2 sec square x tan square x plus tan raised to 4x. Now I have taken this, but what actually it is there? It is only 1. So if I take 3 plus 3 sec square x tan square x, that means plus 3 minus 2 is plus 1. So ultimately we got this. Now can you see, this is a complete bracket square. This is a bracket square of sec square x minus tan square x bracket square, and plus we have 3 sec square x plus tan square x. Isn't it? Very simple. But sec square minus tan square is 1. So we have 1 plus 3 sec square x plus tan square x, which is equal to right hand side. Actually this problem is very simple, and we have solved such problem in algebra also. The only problem is we are not used to, that means students are not used to handle 6 degree with trigonometric ratios. Okay, so but instead of this, if you had a cube, or if you had a raised to 6 minus b raised to 6 is equal to 1 plus 3 a square b square, then you could able to solve it, because you know how to handle a and b, but you don't know how to handle trigonometric ratios. But mind well, handling trigonometric ratios is also extremely similar to your normal variables. So in this case, again I am explaining you, raised to 6 is nothing but sec square bracket raised to cube. Now this is nothing but a cube minus b cube. What we have written here, a cube minus b cube is a minus b, a square plus ab plus b square. So we have these two identities or these two ratios. So now we have a cube minus b cube. So we have written a minus b into bracket a square plus ab plus b square. Okay, but by identity we have sec square minus tan square is equal to 1. So this bracket eliminates. Now here, this can be a perfect square if we have minus 2ab or plus 2ab in between. Correct? But we want 1 here, 1 sec square tan square is there. So to keep it remaining here, what we should do? 2 we want. So either we should take 2 or 1. If we take 2 sec raised to 4 plus 2, then what we have to take here to get it 1? Minus 3. But do we want it here? No. So we will take minus 2 sec square tan square. So here we will take plus sec square tan square. So ultimately we will have only single one here. So you want one answer here, one variable or one coefficient here. So how that one will be splitted? Plus 1. Why we use minus 2 and not plus 2? Because a square minus 2ab plus b square is a minus b bracket square. And we want to use identity, this identity, sec square minus tan square equal to 1. So here we must have sec square minus tan square. To get that, we must have minus 2 here. So if we have minus 2 here and we want only 1 here, actually here only 1 is there. Sec square tan square, only 1 sec square tan square is there. Here we have taken 2. So we cannot just take minus 2 here. We want plus 1 here. So we will add plus 3 sec square tan square. Now this is a perfect square of sec square minus tan square whole bracket square. Now this sec square minus tan square is 1, so that bracket square is also 1, and so we have 1 plus this remaining, which is equal to right hand side. Actually speaking, this kind of this example has got no meaning. They are just testing your ability to handle raised to 6, raised to 4, these powers. Okay, they want to see you can handle a raised to 6 minus b raised to 6, but can you handle powers with the trigonometric ratios or not? Okay, this is a tricky kind of example, so be careful in this case. Let us see next one. Fifth one is tan theta upon sec theta plus 1 upon sec theta plus 1 plus sec theta plus 1 upon tan theta is equal to 2 cosec theta. Now how will you solve this? Very simple. Start from the left hand side. Okay, first multiply, cross multiply, that is a upon b plus c upon d is equal to ad plus bc bd. Let us do that. So this is left hand side equal to tan square theta plus sec square theta plus 1 sec theta plus sec theta plus 1 bracket square divided by tan theta into sec theta plus 1. We will substitute tan square theta is equal to sec square theta minus 1. Sec square theta minus 1. And how about this bracket? Plus sec square theta plus 2 sec theta plus 1. And here I will write same tan theta upon sec theta plus 1. Okay? Now here 1 will get cancelled and we will have 2 sec square theta plus 2 sec theta upon tan theta into sec theta plus 1. Now can you see sec theta is common here? So I will have 2 sec theta into bracket sec theta plus 1 upon tan theta into sec theta plus 1. Correct? Now this two brackets will get cancelled and we will have 2 sec theta upon tan theta. So we will have 2 into 1 upon cos theta into tan is sin theta upon cos theta. Cos theta will go up. Cos theta upon sin theta. So cos will get cancelled and ultimately we have 2 cosec theta, which is equal to right hand side. So this is again a simple example. You have to start with left hand side and come to the right hand side. Just check what is there and try to get that. Try to eliminate as much as possible. Okay. So you have to practice a lot for this kind of examples because every example is different. So my suggestion is go through or get the at least 20 papers of class 10, previous exam papers. Maybe the portion is same or not. Trigonometry is always there. The proofs are always there. Collect all those examples, solve those examples, solve minimum 50 examples, so you will have the mastery in that. And if you solved 50 examples from previous papers, no other than those 50 examples will come in your exam. Okay, so this type of questions you should have a thorough practice. Let us see next one. 1 plus sin A upon cos A, prove that it is equal to 1 plus sin A plus cos A, 1 plus sin A plus cos A upon 1 plus cos A minus sin A. Now let us start with left hand side, that is 1 plus sin A upon cos A. We have got nothing else to do than rationalizing the numerator. So we will multiply and divide it by 1 plus sin A upon cos A, multiply and divide by 1 minus sin A upon 1 minus sin A. So we will have A plus B, A minus B. So we will have 1 minus sin square A upon cos A into 1 minus sin A. From this 1 minus sin square is cos square A. So we have cos square A upon cos A 1 minus sin A as it is. Cos square and cos, one cos will go. So we will have cos A upon 1 minus sin A. Okay. The next step is important. Now you have 1 plus sin A upon cos A and cos A upon 1 minus sin A. Now by the theorem on equal ratios, what we have here? We have 1 plus sin A upon cos A is equal to this, cos A upon 1 minus sin A equal to kc. Now by the theorem on equal ratios, we can add them, correct? That will be also equal to k. And so if you add these two, we have 1 plus sin A plus cos A upon cos A plus 1 minus sin A. I am just rearranging the term. So we have 1 plus cos A minus sin A, which is equal to right hand side. Here actually it is cos A plus 1 minus sin A. I am just rearranging the term. I am taking the cos first. I am taking the number first. Actually the cos should come first. Cos A plus 1 minus sin A. I have just taken here 1 plus cos A minus sin A, which is equal to right hand side. So here we have made use of theorem on equal ratios. This is also we have done in standard 10th algebra and in standard 9th also. Okay, let us see next example. Seventh example is similar to this. You have to again use theorem on equal ratios. The example is tan A upon sec A minus 1. Seventh is tan A upon sec A minus 1. Show that it is equal to tan A plus sec A plus 1 tan A plus sec A plus 1 upon tan A plus sec A minus 1. Same, we will start with left hand side and then we will rationalize this now. Okay, so exactly similar to previous example, I want you to try this. Please pause your video here and try this sum. You have to, after a particular step, you have to use the theorem on equal ratios. Please do it now. Let us solve this. So I will multiply and divide by sec x plus 1. So I have tan A upon sec A minus 1 into sec A plus 1 divided by sec A plus 1. So here I will have tan A upon sec A plus 1 upon A minus B A plus B. So I will have sec square A minus 1. And sec square A minus 1 is tan square A. So I have tan A sec A plus 1 upon tan square A. One tan will get cancelled. So I will have sec A plus 1 upon tan A. Correct? Now you have tan A upon sec minus 1 and you have this. So equal to K. By theorem on equal ratios, we will add these two. So tan A plus sec A plus 1 upon sec A minus 1 plus tan A. Just rearrange the denominator. Take this minus sign last and tan first. So which is equal to right hand side. Example number 8, very simple, straightforward. Left hand side is sec square plus cosec square under root sec square theta plus cosec square theta is equal to tan theta plus cot theta. Tan theta plus cot theta. So we'll start with left hand side. We want tan and cot, but we have sec and cosec. But sec and tan are related there. Sec square theta is 1 plus tan square theta. So we have sec square is 1 plus tan square theta and cosec is 1 plus cot square theta. So from here we will get tan square theta plus 2 plus cot square theta. Correct? But can it be a perfect square? Yes, but along with 2 there should be tan into cot, 2 tan cot. But tan and cot are exactly inverse to each other. So they can eliminate and equal to 1. So we can write it here. Equal to tan square theta plus 2 tan theta cot theta plus cot square theta. Is it not a perfect square? It is a perfect square of tan theta plus cot theta bracket square. And taking square root, we have tan theta plus cot theta, which is equal to right hand side. Very easy. So here we are solving different types of prove that examples. Okay, let us solve next one. Ninth one. 1 upon cosec A minus cot A minus 1 upon sine A equal to 1 upon sine A minus 1 upon cosec A plus cot A. Now remember, in some examples like this kind of example where the terms are same, some signs are changed. Now in this case you will not be able to start with left hand side and go to right hand side. So in that case you can do one thing, you can solve left hand side, you can solve right hand side, and then you can show left hand side equal to right hand side. So let us solve by this method. So left hand side is equal to, we will try to rationalize this. So we have 1 upon cosec A minus cot A into cosec A plus cot A upon cosec A plus cot A minus 1 upon sin A. Right? So what we will get? We will get cosec A plus cot A upon cosec square minus cot square, and cosec square A minus cot square A minus 1 upon sin A. Now cosec square minus cot square is 1, so, and 1 upon sin is cosec, so we have cosec A plus cot A minus cosec A. Now this cosec will get cancelled, and left hand side you have got cot A. Now let us see what we get by right hand side. So let us solve right hand side here. Okay, now take a right hand side, same thing, 1 upon sin A. Now I am doing it very shortcut. If you rationalize this, what you will get? We have to multiply and divide by cosec A minus cot A. So on the numerator we will have cosec A minus cot A, and upon we will have cosec A square minus cot square A, that is 1. So ultimately here we have cosec A minus cosec A plus cot A, because this is a bracket, and when you open this bracket cosec A will be negative and cot A will be positive, and here we have got cot A, and hence right hand side is equal to left hand side. So these kind of examples, see, many times the left hand side is longer one, right hand side is shorter one. In that case you can start with left hand side and come to the right hand side, but here both are same. So probably you cannot start with this and come to this. So in this case what I have done, I have solved left hand side, or I have simplified left hand side, and I have simplified right hand side, and I have shown that left hand side is equal to right hand side. Both are same. So this is another kind of example. Let us go ahead. Now I have to show that something. What I will do, I want to reach here, show that. So what I will do, I will take left and right hand side both. First of all, I want square, so I will square both the sides. So I will tan A plus 1 upon tan A, I will bracket square, I will square both the sides. So we will have, you have to write everything, squaring both the sides, etc. I am not writing it here, but you have to write the reason for your every step or most of the steps. Okay, here you have to write squaring both the sides. I am not spoon feeding you all these things. These are quite obvious things. You have to write the reason for each and every step you are doing. Okay, now, so here this is just like A plus B bracket square. So I will have tan square A plus 2 into tan A upon tan A plus 1 upon tan square A equal to 4. So this will get cancelled, eliminated. So I will have, see, I got a left hand side like that, tan square A plus 1 upon tan square A. Now 4 minus 2, 2 goes to that side, 4 minus 2, that is 2. So proved. Example number 8. Eliminate theta if x equal to a sec theta and y equal to b tan theta. This appeared in March 12 exam for 2 marks. Now whenever you are asked to eliminate theta, in that case you have to use the identities. Okay. Now here they are given x equal to a sec theta, x equal to a sec theta and y equal to b tan theta. Okay. Now we want to eliminate the theta. Okay, that means sec theta must be eliminated. Do we have any identity related to sec? Yes, we have here. Okay, but here it is sec-square. So we will square this. So we will get sec-square theta is equal to x square upon a square. In this case, we will square both the sides. So we will get tan square theta is equal to y square upon b square. And after that, sec square minus tan square, sec square minus tan square equal to 1. So we will eliminating theta in this case. So please pause your video and solve this example. First, square both the sides here, square both the sides. That means you will get 2 equations and then subtract equation 2 from equation 1, and when you subtract equation 2 from equation 1, theta will be eliminated. Please pause your video and try yourself. Let us do this. So we have sec square theta is equal to x square upon a square, and this is our equation 1, and the second equation we get tan square theta is equal to y square upon b square. This is equation 2. Now when we subtract, we will get sec square minus tan square, which is nothing but 1. Now here you have to give the reason, because sec square minus tan square is equal to 1. So I am writing directly 1 here, and here we will get x square upon a square minus y square upon b square, and this is your required answer. Just rearrange the terms, write 1 this side and x square upon a square minus y square upon b square to left hand side, and that will be your answer. Let us go ahead. Second problem of 8th is x equal to 2 cos theta minus 3 sin theta. X equal to 2 cos theta minus 3 sin theta, and we have y equal to cos theta plus 2 sin theta, y equal to cos theta plus 2 sin theta. Now what you will do in this case? Is it not exactly of type simultaneous linear equation kind? Isn't it? There we had 2 variables and we had to eliminate those 2 variables, or we have to find the value of those 2 variables. So here, now here it is cos theta, sin theta, here also it is cos theta and sin theta. Okay. Now suppose we want to eliminate this, what we should do? What we used to do in simultaneous linear equations? First we have to match the coefficients. Correct? Here it is 2 cos theta and here it is only cos theta. So what we have to do? Multiply this equation by 2 and this equation by 1. Of course, no need to multiply by 1, but suppose instead of 1, if it is 3 here, then you have to multiply by 3. So you will get the first equation, and then when you try to subtract this sin theta, you will get the second equation. So in this case, by first equation you will get sin theta, second equation you will get cos theta, and then sin square theta plus cos square theta equal to 1. By using that identity we can eliminate theta. So let us solve this example. First, x equal to 2 cos theta minus 3 sin theta, and I am multiplying this equation by 2 and writing the answer directly. So 2y is equal to 2 cos theta plus 4 sin theta. So by subtracting, what I'll get? X minus 2y is equal to 2 cos theta, and 2 cos theta will get cancelled, and here we have got minus 7 sin theta. This I will call equation A or equation 1, whatever you can call it. Okay. Now similarly, here I have eliminated cos, here you will eliminate sine. Now to eliminate sine, both the coefficients are different, so we will multiply each equation by other equations sine coefficient. So multiply first equation by 2 and second equation by 3. Let us solve this. So here I am multiplying by 2, so I get 2x equal to 4 cos theta minus 6 sin theta, and now I am multiplying the second equation by 3, so I will get 3y is equal to 3 cos theta plus 6 sin theta. 6 sin theta will get cancelled. 2x plus 3y is equal to 7 cos theta. This I will call equation B. Now this is exactly similar to previous example. There we had only sec and tan. Here we have sine and cos, and sine square theta plus cos square theta equal to 1. You have sine, so multiplying both the sides you will get sine square theta, and here multiplying both the sides you will get cos square theta. So please pause your video here and do this final step. Please pause. Let us solve it. I am squaring both the sides, so I have x minus 2y square is equal to 49 sine square theta, and here I will get 2x plus 3y bracket square is equal to 49 cos square theta. Correct? Give some number to this. I will say 1 and 2, or if you are given number 1 and 2 here, you can write 3 and 4 and so on. Okay. Now what we will do? We will add 1 and 2. Okay. So what we will have? X minus 2y square plus 2x plus 3y square is equal to 49 sine square theta plus cos square theta. Sine square theta plus cos square theta equal to 1. So finally I will get x square minus 2y bracket square plus 2x plus 3y bracket square is equal to 49. This is your required equation where no theta is there. That means theta is eliminated. Very simple, just little bit lengthy, okay, but you will get definitely 2 marks here. So let us go ahead. The third sub question is exactly similar to the previous one. X equal to 3 cosec theta plus 4 cot theta, x equal to 3 cosec theta plus 4 cot theta, and y equal to 4 cosec theta, y equal to 4 cosec theta minus 3 cot theta. Very similar to previous 2 examples or the previous example. First, decide which identity you are going to use. Cosec square minus cot square equal to 1. That identity you are going to use here. But both are present in each equation. So what we have to do first you have to find out the cosec theta. Then find out the cot theta. How you will find out that? Very simple. Multiply the first equation by 4 and second equation by 3. So coefficient of both the cosec will be same. Then you subtract and you will get the cot theta. Then multiply the first equation by this coefficient of cot theta 3 and second equation by 4, and cot will be same, eliminate, and you will get the cosec theta. Now in this equation you have only cosec theta, in this equation you have only cot theta. Square both the sides and then subtract, and you will get cosec theta minus cot theta equal to 1, and at last theta will be eliminated. Very simple example. Please pause your video here and try to solve yourself. First I am going to eliminate cosec theta and cos theta. So the first I will multiply this equation by 4 and this equation by 3. So here I will get 4x is equal to 12 cosec theta plus 16 cot theta, and by multiplying second equation by 3 I will get 3y is equal to 12 cosec theta minus 9 cot theta. Now I have to subtract. Here 4x minus 3y is equal to 25 cot theta. This is A I got. Here only cot is there. Second step is multiply the first equation by coefficient of cot. So I am multiplying by 3, so I get 3x equal to 9 cosec theta plus 12 cot theta, and multiplying this equation by 4 I get 4y is equal to 16 cosec theta minus 12 cot theta. This will get cancelled, so I got 3x plus 4y is equal to 25 cosec theta. So now this is my equation B. So I am squaring both the sides of both the equations. So I will get, you have to write that, squaring both sides. So I'll get 4x minus 3y square is equal to 625 cot theta. And here I will get 3x plus 4y square is equal to 625 cosec square theta. This is my equation 1 and equation 2. Now I want cosec square minus cot square, so I will subtract first equation from second equation. So here I will get 4x minus 3y square equal to 625 cot square theta. I am subtracting now, so finally I will get 3x plus 4y bracket square minus 4x minus 3y bracket square is equal to 625 into bracket cosec square minus cot square theta. Cosec square theta minus cot square theta. Now cosec square theta minus cot square theta equal to 1. So here I get, final answer is 3x plus 4y square minus 4x minus 3y square is equal to 625. So friends, here we have finished exercise 4.3, and now we will go to applications of trigonometry. Thank you.